So in this example, we're trying to multiply two brackets together. What does that mean? Well, imagine the brackets were the sides of a rectangle. So we've got x plus 3 multiplied by x plus 5. They're the two sides of our rectangle. Well, we know when we multiply the two sides of the rectangle, we get the area of the rectangle. And in actual fact, we can split this rectangle up into 4 different sections. And there they are. Now, let's find the area of each of the individual sections, and that will give us the area of the whole rectangle, and therefore it will give us the answer to our expression. So what's the area of the yellow square? Well, it's x times x. It's a square. That must be x squared. The area of the pink rectangle. Well, it's 5 multiplied by x. We know what 5 times x is. Of course, it's 5x. The green rectangle, x times 3, or 3 times x. Well, that's 3x. And finally, the smaller blue rectangle, well, that's 5 across and 3 up. So that's an area of 15. So our total area, we need to add these 4 expressions together. When we add them together, can we add an x squared to an x? No, we can't. So we've just got 1x squared. But we can add 5x to 3x. That makes 8x. Can we add 15 to the x's and get 23x or something like that? No, we can't. It's just plus 15 at the end. And that is our expression. So x plus 5 in brackets multiplied by x plus 3 in brackets is equal to x squared plus 8x plus 15. We're not going to draw the rectangle this time, but we're going to set it out in a very similar way with a little multiplication grid. It's just a bit quicker. So imagine one of the sides is 2x plus 3 and the other side is x plus 5. Now we can start multiplying the separate sections. 2x times x, 2x squared. 3 times x plus 3x. Plus 5 times 2x is plus 10x. And finally, 5 times 3 is plus 15. So when we put the 4 terms together, this is what we get. 2x squared. We then put the x terms together. 10x plus 3x is obviously plus 13x. And finally, plus 15 at the end. So 2x plus 3 in brackets multiplied by x plus 5 in brackets gives us 2x squared plus 13x plus 15. We set this out in exactly the same way. 3x subtract 1 on one side, x plus 2 on the other, and we multiply the sections. 3x times x, 3x squared. X times negative 1 is negative x. 2 times 3x is 6x. And finally, positive 2 times negative 1 is negative 2. So we put the 4 terms together. We have 3x squared. Just be careful with the x term. We're adding 6x and we're subtracting x. So adding 6x and subtracting x is the same as adding 5x. And finally, we've got subtract 2. So 3x subtract 1 in brackets multiplied by x plus 2 in brackets gives us 3x squared plus 5x subtract 2. This looks like the other two examples, but you have to be careful with the signs here. We set it out in exactly the same way. 2x subtract 5 on one side, x subtract 1 on the other. We multiply the 4 sections. 2x times x is 2x squared. Negative 5 times x is negative 5x. Negative 1 times 2x is negative 2x. And then a negative 1 times a negative 5 is plus a positive 5. And we put the four terms together, 2x squared. Be careful with the x term. We're subtracting 2x and we're subtracting 5x. So we're subtracting 7x. And our final term is plus 5 on the end. So 2x subtract 5 in a bracket multiplied by x subtract 1 in a bracket gives us 2x squared subtract 7x plus 5. This example highlights a very common error. There are lots of students who will look at the question and think, okay, that must be x squared plus 2 squared, so the answer is x squared plus 4. I'm afraid not. We can see why in this example. If we put x equals 3 into the bracket, would 3 plus 2 all squared equals 3 squared plus 2 squared? Or 3 squared plus 4? No, it wouldn't. Therefore, we'll still use the grid method and we'll see what the answer should be. It's x plus 2 on one side times x plus 2 on the other. The four areas, when we multiply them together, x squared plus 2x plus 2x, and finally plus 4. So when we put that together, we have x squared. Note now plus 4x. In our original wrong answer, we didn't have plus 4x, and then we get plus 4. So it's really important that you think this one through. Don't lazily jump to the wrong conclusion and use the grid method.